And people that just joined, welcome. We've sent a small form for people to fill. It's true. While we are still waiting, please, if you know you have not subscribed to my YouTube channel, you are in the wrong. Just so you know, you are in the wrong. I'm going to send the link now. Please subscribe. Hey Joe, you don't want me to chop. I don't know what I did to you. If you're not sure that you have subscribed, it means you have not subscribed. Subscribe again. Thank you. Okay, I think the most basic thing we are going to talk about, like the first thing we should talk about. Hey, can you guys hear me? Hello. Okay, all right. So the first thing we should talk about is IP address. I think that's the basics in networking because networking is mostly about uses IP addresses. So when you hear IP address, what do you think about, right? So I'm sure we have already seen this kind of set of numbers joined together. For those that have done the labs, hey, check your EC2 public IP, you can see, or private IP, you can see something like this, right? So the truth is that this is actually this, right? So computers, they basically communicate with numbers, with binaries, ones and zeros. However, us humans, we communicate with letters, with alphabets. So if I tell you to remember if I tell you to remember 192.168.75.90, or I tell you to remember exam.pro, which one will be easier for you to remember? Obviously to be exam.pro, that will be easier for you to remember. So all devices, all computing devices, your phones that are going through the internet, they all have an IP address. The IP address is like your unique identifier. Just like everybody in Nigeria has NIN, other countries have social security numbers, computers have their own IP address. And this IP address that you see here is actually combinations of ones and zeros. Remember, the computer just understands ones and zeros. So most of everything, even the programming, everything, the computer translates it to ones and zeros. So this number, if we translate it to ones and zeros, will actually give you this value. So this is actually what the computer is seeing, while you might be seeing this on your instance, but when you now go to the web browser, you will now be seeing maybe youtube.com, google.com. Yeah, those are what we call domain names. All right. So in our IP address, we have what we call the network part and the host part. So the network part is basically used to identify where the IP address is coming from, and the host part is used to give each device a number. So basically, what I'm saying is, for example, MTN, right, can say we are using this whole part. So any IP address you see with 192.168.75, you know that it is from MTN. So now MTN has a lot of devices, right? So each device, like each SIM card that MTN gives out, like as you're browsing the internet, you can say, okay, this is 192.168.75.1. Next person is 192.168.75.2, the 3.4.5. So for each part, each device in the network will have the host. The host is what changes, but the network, that is the identifier, remains the same. Right. So how do you then know which part of your IP address is the network and which part of your IP address is the host? We have what we call subnet mask. If I'm going too fast, please someone should stop me. Does everyone understand? If you don't understand, say I don't understand. Okay, so I'm assuming everyone understands. So now is your subnet mask that will help you differentiate which part of your IP address belongs to the network and which part belongs to the host. So your subnet mask is basically should I say this whole IP address in full. So we have 255.255.255. How do we get this 255.255.255? Like I told you earlier, these numbers are basically ones and zeros and ones and zeros. So if we have this whole part, okay, I think I forgot to mention something earlier. Let me go back. So this is IP version 4, right? So in IP version 4, you have four sections, one, two, three, four, and it's each four sections is divided into eight numbers. Ones or zeros eight times, ones or zeros eight times, ones or zeros eight times. Right. So let me go back to so for this 255 now, if you convert this particular section, that is this particular section, if you convert it to hexadecimal format, you get 255, and this is the highest that you can get in a particular set of numbers. Like 111 is obviously the highest. You can mix it 1010 to give different numbers, but this is the highest you can get. 255, 255.255.255. So now this your subnet mask. Right? It's saying that this place, this is the highest you can get. This is fixed. This is fixed. This is fixed. But this part that is zero is the part that you can change. And so from our subnet mask, if we fix all these, it means we can now change this. So in essence, what we are saying is since we are fixing all these, we are fixing this part, we are fixing this part, and we are fixing this part. You know this part has eight numbers. That is one or zero, one or zero, one or zero, eight times. This part also has eight numbers. This part also has eight numbers, and this part has eight numbers. Right, so if we can add this is eight plus eight plus eight. Right, this will give you 24. So if we add this set of eight, right, this set 24, we can also write it like this. So meaning we are fixing the first 24 numbers and we are allowing you to change this part. This is your CIDR range. Let me explain that again. So like I said, this is IP version 4, and all these numbers, right, they are binary numbers, and they are one made up of ones and zeros eight times in each section. So to know the part that is your network part and the part that is your host part, we can use this CIDR notation. So when you see this slash a number here, it means the amount of numbers here are fixed, right? So we count from the left, from the left to the right. Okay, so we are counting eight numbers here. Remember, it's ones and zeros. Eight numbers here, eight numbers here, and eight numbers here. So that will give, this will be 24. And if it was 23, you count eight, eight, and seven numbers. That means there's a certain degree of how you can change this particular number here. So that's basically our CIDR range, and that is what is going to give you the amount of IP addresses that a CIDR can give you. So the total amount of that's why if you see a fixed IP address, a fixed IP address will have /32, and this is because if we add all the eight here, we can see that everything is complete and then there's nothing left for us to change. Like there's nothing in the host portion for us to change. Does everyone understand? Hello, any questions so far? Okay, what part exactly do you not understand? Okay, so let me go back. Okay, all right, all right. So this, see this is IP version 4. You notice there are four parts: one, two, three, four. This is an IP version 4 address, right? So now these numbers, the computer do not understand these numbers. It changes it to ones and zeros. So if you translate this number in binary, this is going to give you this exact number. And if you check it, this is one, two, three, four, five, six, seven, eight. This is eight numbers. One, two, three, four, five, six, seven, eight. On that set of eight, eight and eight. So these are all eight numbers. Eight, 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 eight. Do you get? Okay, so now that you get that part, when you convert it to hexadecimal format, it will give you to give if you convert this, it will give you 190. You can check it with your calculator. If you convert this, it will give you 168. If you convert this number, you get 75, and if you convert this number, you get 90. Right? So what I want us to do is to check our CIDR, what we call CIDR. Okay, so before I get to CIDR, in our IP address now, we have the network part and the host part. The network part is the part that identifies the network. Like I gave an example earlier. I said, for example, now, MTN can say, if we see any IP address that starts with 192.168.75, you know that it is from MTN. If you see any IP address that's like 192.168 dot maybe 73, you know that it is from Google. So network is basically used to identify like the company or the group that owns that IP address range. Then the host part is the part that changes. The host part is basically used to identify used to give each device in that network an IP address. So for example now, we all have, okay, I'll not say we all have, a lot of people have MTN sims. So if MTN now declares that um this, I'm not saying this MTN's subnet this thing. No, I'm just saying if MTN declares that this is their network address, this 192.168.75, the network address, that means devices that have MTN, like devices that use MTN, they will have IP addresses of 192.168.75.3, 192.168.75.4, 192.168.75.5. Do you understand? Okay, so okay, thank, so far you understand. So now, they don't usually write network and host parts in red and blue ink, right? So how do you know which part is the network part and how do you know which part is the host part? That's where we use subnet mask. You can use subnet mask or you can use CIDR block. Now, for your subnet mask, the total amount of numbers you can get here, because you know it's 1111, like we saw earlier, this whole place can be 1111. If you convert this to um if you convert this to hexadecimal format, you get this 255. So that's like the total amount you can get out of this whole IP address. Like out of this whole set of numbers, 255. Out of this whole set of numbers, 255. Out of this whole set of numbers, 255. So basically, your subnet mask is saying that this 255, we are holding this 255, like we are holding the total amount of numbers here, holding the total amount of numbers here, holding the total number of amount of numbers here. Then this dot zero means you can change this part. So it's basically telling you that these first three numbers or this first three set of numbers, you should not be able to change it. But this last one, you can change it. Do you get? So there's also another way of writing this, which is using the CIDR block. So using the CIDR block, we use slash a number outside here. This is what we call a CIDR block, right? CIDR notation. So instead of doing 255 to 255 255, we count the numbers that we are holding. So let me go back to this place. So if we are doing this now, this is what this number is. So if we are holding one, two, three, four, five, six, seven, eight. We are not changing these numbers. We are not changing these numbers. We are not changing these numbers. If we add eight numbers plus eight numbers, that is 16. Plus this set of eight numbers, that will give us 24. Meaning that we are not changing this set of 24 numbers. You are free to change the remaining eight. So do you understand? Do you understand what I just said? Okay. So now, how do you know the number of IP addresses that you can give that is still left or that is still available? So if we are holding this set of three numbers, it means that we can now change these numbers, and then we can change it in any we can make it 11111. We can mix it anyhow we want to mix it, right? But we just have eight numbers to mix. So since we have eight numbers to mix, and if you did further maths, the whole permutation of all this is to know the amount of IP address you can give from this part. You just say 2 raised to power 8. That is the 8 remaining left. But we're not going to go into all that. For our AWS, I don't think we need to calculate that. I'm just saying this so that when you see this range, this CIDR, you will not be confused, because this is the basics of networking. Okay, so let's go to our VPC. Where am I? Okay, this is my VP. This is my personal account, so I'll not be creating much here because that's going to rack up bills. I'm going to do the tutorials or the demo in the next lesson, but I just want us to understand some things now, some parts of the theory, because the theory in networking is actually much. All right, so this is what I was talking about, our IP version 4 CIDR block, right? So now we can see this slash 16. What does this slash 16 means? It means we are holding 16 numbers, right? So if you can, this here is 8 numbers. The next set is 8 numbers. It means that if you create this VPC like this, it means that all our resources, right, all resources in this VPC will have this 10.0, right? And then we can now change this 0.0. Like this other part is changeable. But once you see 10.0, you know that, oh, it belongs to this VPC that we created. Do you guys understand? So increasing this slash 16, or sorry, decreasing this slash 16 will decrease the number of IP addresses you can use in that VPC, because like I said, this slash 16 indicates that we are holding this portion, right? So if you now decide to hold this portion, you just have only 8 numbers to play with. Therefore, you're decreasing the amount of IP addresses that you can create in your VPC. So if you do 24, you see that it has decreased significantly because you have reduced the number of IP addresses, right? You must not also do 8. You can also do 23, 22. You can see it that as you are reducing the numbers, the number here, the IP address increases. But as we increase the number here, the IP address reduces, right? So what is the maximum amount of, what is the max that can be here? This place. Someone should give me an answer. Yes, 32, correct. Because why is it 32? Hello? Hello? Exactly. 8 in 4 places. Yeah, but AWS will not allow you to create 32 here, because they have a range which your VPC must belong to, between slash 16 and slash 28. Then we also have what we call IP version 6 CIDR block. So this IP version 4 is just this 8 divided in 4 places. But IP version 6 now, we are introducing numbers and alphabets in our IP version 6 address. Because IP version 4, I think there's a limit to how many IP addresses you can actually take. And as we are growing, everybody's creating new devices and everything. Everybody wants to get on the internet, so this IP version 4 cannot hold the amount of IP addresses we have in the world. That's why IP version 6 was created. But I don't think we have much to do with IP version 6 in this AWS course. So let's focus on what we are reading for this thing. I just explained this because someone asked me about CIDR blocks. Okay, so when you're creating your VPC is like an isolated portion of your network. It's basically where most of your resources are going to be created in. And I say most of your resources because some resources get created outside of your VPC. Resources like your S3 and your, I think, DynamoDB doesn't get created in your VPC. But things like your EC2 get created within your VPC. Whenever you see when you're trying to create something and it asks for you to select VPC, it means it gets created in your VPC. Your VPC is basically your own space in the cloud. Um yeah, so let's move on. I'm sure we all know what availability zones are, so I'm not going to dwell on that. So I'll just take us from this panel. We'll be going down. Right, so I've explained VPCs. The next thing is subnets. You guys know that if you don't understand anything, you can always go to your panel and then just click on info, and then you see more information about what you want, what you're talking about. So these subnets, let me put okay. So AWS architecture icon. For those of you that don't know how to do the architecture icon, just search for your AWS architecture icon and then look for the one that you actually want. Me, I'm familiar with draw.io. Some people might be using Figma. Shout the one that you want, and then you can just click on it and you log in and your details will be there. All right, so VPC. Okay, like this color. All right, so this VPC is basically your own space in the cloud where your resources will be, most of your resources will be. So now your VPC can have, let me put it, now let's say your VPC has a range of 10.0.0.0/16, right? So what your subnet is, this VPC is like all the resources in your VPC will have a range, or will have like this range of IP addresses, right? So what your subnet does is it breaks it down. Like this subnet, or this range of IP addresses might be too large. It's like it segregates it. So you might say, okay, I want some parts of this VPC to be private, I want some parts to be public. So that's the whole point of our subnet, to break down the network in our VPC. Who understands that? Does anybody understand that? If you understand, say I understand. Nobody understands. Hello. Tough crowd. Okay. So now this is our VPC, and then to break down this network, we can put one public subnet and you can also put another private subnet. All right. Let me just enlarge this. Let me take this here. Okay, so let me just enlarge this. Ideally, these subnets will be created in availability zones. Zones are the locations of your resources. So this subnet now will now be part of this your range of VPCs. VPC. Um so if we're having something like 10.0.0.0/16, we can come here. Let's just say this subnet can be um can be 10.0. Remember, we are holding 10.0 constant because it is /16. That's the part we're holding constant. So we can say 10.0.0.0/24. What does this mean? It means we are now holding 10, 0 and this 0 constant, meaning you can change this 0. So if you notice that this is still part of your this IP address range, this CIDR range is still part of your VPC CIDR range, because in your VPC you're holding 10.0, but here we are now holding 10.0.0. Do you guys understand? And so for our private subnets, we can also let's see, I'm going to copy. Sorry. So for our private subnet, we can also okay, we can also say this subnet range will be 10.0.1.0/24. I don't know if you guys understand. This means we are holding 10, we are holding 0, we are holding 1. So the next thing that is available to change is this set of numbers. And if you notice, it's also still part of this our VPC CIDR range. So basically that's what our subnet is. Our subnet is just basically to divide our VPC's network. So now as we have divided it, we can now say, okay, this part should be public, this part should be private. So that's just basically what our subnet is for. If you read the definition here, it says a subnet is a range of IP addresses in your VPC, right? So I hope you guys understand that part now. If you don't understand, please just call me back at any moment. We are still going to create our VPC, but I just want to explain these things first. Right, next we have our route table. So what a route table does is to just say a route table is like the snitch. Like you're in a group and like, okay, this guy is there, that guy is there, right? So your route table is just the snitch in the group, or to tell you where what is what. So when you create a VPC, a default route table gets created. And this default route table, it just shows that if you're going, let me open one and see. Let me check. Is this default one? Okay, this is not the default one. Chill. I just want to open. I've already edited this thing, so I don't even know if the default one is still here. But when we get into, okay, I've edited both of them. When we get into um let me remove this, save changes. Okay, so your default route table will basically look like this. Right? This is the VPC CIDR for this VPC that was created. So it just basically says that the destination for all this IP address range, right? This is destination and the target is local. So basically just basically says that all devices in your VPC can communicate with each other. And so once you create a VPC, you get a default route table which you cannot delete. See, if you try and delete this, you see now I can't delete this. This means that all resources in my VPC should be able to communicate with each other. If you look, see, I can't do this. But if I add something, I can remove it. But this default route one, I cannot delete. Okay. So this default one, it just says that I can talk to all the resources in my VPC can communicate with each other. So like I said, your route table is basically like your snitch. So you tell it if the person is going, this 0.0.0/0 stands for the internet. So if we are going to the internet, right? If this is your destination, you should go you should go here. You should use the internet gateway. You should use the NAT gateway. You should use career. You should use any of these services. You should use peering. It just says, oh, it also, we can also say maybe it's like a Google map, right? So if this is where you want to go, you should use this device or you should use this service. That's why for your public subnet, remember your public subnet is just a regular subnet till you connect it to your internet gateway. Internet gateway is what enables your devices in your VPC to communicate with the internet, and is also what makes your subnet public. So with our route table, we are just saying if your destination is the internet, right? Ask internet gateway. Internet gateway will know how to get you to the internet. So you can just add this. And then this will be what will be adding to our public subnet. But if it's a private subnet, for your private subnet, you don't actually want it um you don't want an open or two-way communication with the internet. For your private subnet, you want to be able to communicate with the internet, but you don't want the internet to talk back to you, like to talk to you whenever it wants, to prevent unauthorized access. So for your private subnet, you tell it if the destination is zero, is the internet, you want it to go to where your NAT gateway. We'll talk about NAT gateway later on. Alright, so that's just basically what route table does. Route table is if you want to go here, check this place. That's what route table does. So therefore, your resources in your VPC cannot go to anywhere that is not specified in your route table. And this default route table ensures that resources in your VPC can communicate with each other. That is why when you have two VPCs or when you do VPC pairing, we'll get to that later. But when you want two VPCs to communicate with each other after enabling other factors, you still have to come here and edit the route and say if this is your destination, go here. So it's your route table that will make sure that your VPC knows that there's another VPC it needs to talk to. Alright, so next we have our internet gateway. Our internet gateway is basically how we communicate with the internet in our VPC. So let me go back here to add our internet gateway to our drawing. Internet gateway. Okay, just like a cool picture. So our internet gateway is usually like the doorway of our VPC to the outside world. You cannot communicate with the outside world. Well, you can communicate without the internet gateway, but through if you want to go through to the internet, yes, you need an internet gateway to go to the internet. Like I said, it's the gateway to the internet. That it's like the door out of your VPC. So basically what this internet gateway does is that once when you create some resources, let's create an EC2 instance. Here we are creating instances. If only it was this simple. Yeah, so let's create our EC2 instance. Now let's say this EC2 instance has a where is it? Copy. Let me see this one. Oh my god, why did I paste? Okay. I'm looking for text. Okay. Let's say this is the instance has an IP address of 10.0.0.25. Okay. This is the public subnet. Okay, so if you notice, your most of the time your public IP address might not be what you've given it, like might not be within the range you've set in your VPC. Right? So basically what this internet gateway does, when you have a public address, when you have a private. Let's say this is private. Let's say this is private, and this is your private IP address. If you noticed, we always have a private and a public IP address. The private IP address is what resources within your VPC usually use to communicate with each other, right? So the public IP address is what is to communicate with the internet. So you can reach it from internet or from wherever. Uh let's just say this. This is even possible. Okay, let's see public. Okay, so basically, your resources in your VPC, when they communicate using the private IP address to each other. But what this internet gateway does is that as you have this your EC2, as it wants to communicate, right, to another resource that's outside or that's on the internet. So as this 10.0.25, as it passes the internet gateway, right, it gets changed to this public IP address. So that's basically what your internet gateway does. So it's this public IP address that people will not see online and use. But when it is coming back, right, it changes it back to your private IP address, and then um obviously your private IP address knows what to communicate, like which device owns that private IP address. But your internet gateway is the one primarily responsible for that conversion. And so now we have let me see what's next. Is it okay? Nat Gateway is still down. Alright, so that's basically what our internet gateway does. Our internet gateway is a horizontally scaled, redundant, and highly available VPC component that enables communication between your VPC and the internet. So this definition is just very simple. You can use internet gateway to communicate with the internet. I don't think there's anything simpler than that. Next, we have egress only internet gateway. So egress only internet. Okay, I think before we talk about egress only, we need to talk about NAT gateways so that you guys will understand NAT gateways first. Okay, so then we talk about NAT gateways. So your NAT gateway, this thing is actually long. You can use a NAT gateway to enable instances in a private subnet to connect to services outside your VPC, but prevent such external services from initiating a connection with those instances. Alright, so what this basically means is that your private subnet is not connected to the internet gateway directly. Your private subnet is just not connected to the internet gateway, right? Because you don't want resources, you don't want hackers or wherever to hack your network and then enter your private subnet, or the resources to access the resources in your private subnet. That's basically why we do not want it to connect to the internet. We can you put our mostly I think most times people put their databases in their private subnet. They put very confidential, important data in your private subnet. Right? So while you have very important data, maybe when on an institute instance, you might actually want to maybe update the instance. You might actually want it to communicate to the internet, maybe to download some certain files or maybe a new update or something. But you still do not want people from the internet to reach you. Let me put your users. Alright. You don't want these niggas here to talk to you, but you just want to be able to go to the internet and then, or we just call them hackers. We don't want these hackers here to talk to you, but we still want to be able to go to the internet and then download the certain files that we need. So the solution for that is having a NAT gateway. Oh, why is this mouse not clicking? Okay, a NAT gateway. So this our NAT gateway, because we want it to talk to the internet. And remember, it's basically only through our internet gateway that our resources can communicate with internet. We put this NAT gateway in our public subnet, because our public subnet has access to the internet. So if you put your NAT gateway in your private subnet, it means that you don't want your resources in your private subnet to communicate with the internet, right? But if you want it, because there's we have public NAT gateways and we have private NAT gateways. So if you want a public NAT gateway for your resources to communicate, for your resources in your private subnet to communicate with the internet, that is when you put your NAT gateway in your public subnet. So what this NAT gateway does, um basically, let's create another resource here. Let's see, copy. um did I copy this? Please, if anyone doesn't understand, you can always draw me back. Do you understand? What don't you understand? Please draw me back. Okay, so I'm just going to assume everybody understands. Okay, so basically what this NAT gateway does is that this is your EC2 instance, and let's say we have a an IP address 10.0.1. Remember, we are holding the first three numbers, right? .1 dot, let's say, whose birthday is who is 62 here? Dot 62. All right. So this is the private IP address of this instance. So basically, what this NAT gateway does is that this, when you route it, or when you remember, like I said, you always have to tell your route table where the resources are. So I've already explained that when you're setting up a NAT gateway, you also need to set up or configure it in your route table. And so basically, any new resource or any new let's say network resource that you're setting up, you need to tell your route table, because the route table is the gossip queen that will tell everybody that, oh, if you're going here, you should go there. All right. So basically, what this NAT gateway does, this NAT gateway will also have a public and private IP address. Let's just move this here because like obviously you can't move your. I'm just moving this here for example references, example purposes. Okay. So basically, what this NAT gateway does, when this NAT means network address translation, right? So this EC2 instance will communicate to the yeah. Let my laptop hanging. All right. Gosh, sorry. Okay, so this EC2 instance here, we just say this is the private IP address of the EC2 instance. This EC2 instance will pass through this NAT gateway, and when it passes through the NAT gateway, what will be communicating or what will be going to the internet will be the private instance of the NAT gateway. So this private instance will now come, hey internet gateway, what's up? And the internet gateway will now translate it to the NAT gateway public IP address. I don't know if you guys understand. Does anyone understand? I should go again. Okay, I'm gonna assume everyone understands. Okay, all right. So let me just write this here. EC2, right? Private. Let me write this NAT gateway private, and this is the NAT gateway public. So this is the private IP address of the NAT gateway, and this is the public IP address of the NAT gateway. So what I'm saying is that when your instance wants to communicate with the internet, right? When your private instance, first of all, to check the route table, to ask route table, how far I want to talk to the internet. Route table will now tell it, I want to talk to the internet, go to your NAT gateway. It's now come here, I want to talk to the internet. So what this NAT gateway does is to translate this private IP address, right, from the from this EC2 one to the private IP address of your NAT gateway. So now with this private IP address, with this your NAT gateway, now this one cannot directly talk to the internet because you do not specify it should talk to the internet in the route table, but it can talk to the NAT gateway. So you know that this your NAT gateway has access to the internet gateway. So it will now come here, hello, to the internet gateway, I want to talk to outsiders. So the internet gateway now will now change this private IP address, will now change it to a public IP address. But this public IP address will be the public IP address of the NAT gateway. So basically, if you want like you want, I think I saw one question. I think there was a question. Let me check if it's here. Um okay, let's read this question. You have an application running on multiple EC2 instances in a single availability zone, right? The application calls a third-party API via the internet. How can you provide the third-party API with a single IP address to access the single IP address to add to an access safe list? So basically what this question is trying to say is that, let me draw this scenario. You have multiple you have multiple um you have multiple EC2 instances, right? So as you have multiple EC2 instances now, you have an application. Let me go back to the question. You have application run on multiple EC2 instances in a single availability zone, right? The application calls a third-party API. Just basic, what all this grammar, just basically saying that this application, right, calls another application or let's say an API. Let's just put that as Control C, Control V. Let's say it calls another application outside. So basically, we now want this. Let's just say this now is the instance. These are our application here. This now is the instance. Let us text. We are assuming this is our other our API, or another where we get our API call from, application where we get API calls, or where we drive our API. I'll just put it like this. I'll just search into API. All right. So we want this. We want to limit the access of IP addresses coming into this, right? So that's where we are. That's what this access safe list does, right? So we are just writing a list of IP addresses that can access this resource. So now we just want to use only one IP address to access this resource. So this solution is, if we put all these our EC2 instances here in our private subnets, when we want to talk to the internet, where would they go to? They will go to the NAT gateway. So this IP address, let's have another EC2 instance. This IP address, let's change this to 68. This is another EC2 instance. This is another EC2 instance. Okay, so we have three instances here. These are our private instances. So it will come to the NAT gateway. All the NAT gateway do, it will change it to the private IP address of the NAT gateway, and as it passes through the internet gateway, it will change it to the public IP address of the NAT gateway. So we can just put only the public IP address of the NAT gateway. Do you guys understand? I assume that everyone understands since nobody's even there. Okay, so now that I've explained that, let's and this is actually a lot. So a public NAT gateway enables instances in a private subnet to connect to the internet but prevent them from receiving I don't know if I mentioned this, but this communication with the NAT gateway is a one-way communication, right? So I think I mentioned it before. So the instance, this NAT gateway, it can talk to the internet, right? But users here cannot say, oh, let me talk to the NAT gateway first. It's like I can call you and you can pick, but you cannot call me because I will not pick. I'm sure we all have friends like that when you call them, they will never pick. Okay, so basically that's what NAT gateway does. Um okay, you should associate an elastic IP address with a public NAT gateway and attach an internet gateway to the VPC containing it. And so when creating a public NAT gateway, you always have to create an elastic IP address. Elastic IP address is basically an IP address that does not change. If you notice, most of your other resources, their IP address keeps changing. If you create an instance and you put it off, you stop it and start it again, you check that your IP address has actually changed, right? But an elastic IP address is just like a semi is a permanent IP address till you delete it, sha. But you obviously get charged for having a permanent IP address. You get charged more for having a permanent IP address. So a private NAT gateway enables instances in private subnets to connect to other VPCs or your on-premises networks, right? But prevents any unsolicited inbound connections. So basically, your private NAT gateway, you can talk to other VPCs with your NAT gateway, but not the internet. Like I said, anything is whenever you see private, just know that this one cannot go to the internet in the whole of networking. Whenever you see private, just know that this one cannot enter internet. So let's move from there. I'm hopeful everyone understands. Does everyone understand? Yes, everyone understands. This is such a great teacher. Okay, so the next thing you are going to talk about is egress only internet gateways. So this egress only internet gateways, remember I've talked about IP version 4 and IP version 6. While NAT gateways is strictly for IP version 4 addresses. So we also have IP version 6. Like I said, IP version 6 consists of both numbers and letters. Right, you see, and it's not even divided by colon, not even dots again. Sef. I think IP version 6 should be something like that's something like maybe I'm sure all of some people have seen something like this. I don't know if I'm writing you sha, but you shall get the draft.